So hello guys, we'll be studying about buffering today. So you might wonder what buffering is. So buffering is a very simple thing I'll be showing you with the help of this picture. So this is a picture that I've taken out from the book from ITC 20. What you can see is here they have red, which is a main road, and I don't know if you can see it, but like there are small minor roads as well represented by the yellow line, and you see some kind of a thicker polygon that is at the both side of the road, and that is buffer. So actually, buffering is one kind of spatial analysis which we do in GIS, and we do that to see how much area is occupied near that place. For example, in this case, with the help of buffer, so red line which you see might be representing the main road, and when we create a buffer, for example, here they have said it's 75 meters. So what it does is it creates a buffer 75 meters at the right hand side and 75 meters at the left hand side. So it will create a 150 meter width polygon, and from that we can count the number of other things that are inside this polygon. So this kind of analysis can be used in different purposes. For example, if I have healthcare centers which are beside the road, and I just want to count how many healthcare centers are there beside the road from point A to point B, then what I can do is first I'll create a buffer, and then I'll count the polygons that are inside that buffer, which will eventually give me the number. So that kind of analysis can be done with the help of buffer. At the same time, if we want to see how many buildings have encroached a riverside, so at that case as well, we can use buffers. For example, if we have digitized houses that are beside the river, and if we create a buffer of 50 meter from the river center line, which we'll be doing in the upcoming example, what you'll see is we can see how many houses have encroached or how many houses are there within the 50 meter of the river center line. So those kind of analysis can be done with the help of buffer. So we'll be studying about this buffer in this video. Okay, so first of all, I just showed you some examples. Now we can look at the theory as well. So like previously in the past video, we looked at overlay operations, right? So in this video, we'll be focusing on neighborhood analysis, and as well as specifically, we'll be studying about buffer. So what is buffer? So overlay operations and this neighborhood analysis are two different kind of spatial analysis, are two of the different spatial analysis that we can do in GIS. So in overlay analysis, so I'll just give a comparative analysis so that you will know what overlay analysis is and what neighborhood analysis is. So overlay analysis, it compares or combines the values of a location from multiple data layers, right? So it deals with individual locations, exact points, polygons, or cells. Some common methods of overlay analysis are clip, intersection, union, difference in case of vector, and in case of raster, it was arithmetic, logical, and comparison operators, which we had seen in the previous video. Right? So in the overlay analysis, what you can see is we have two different layers. We overlay them and we create a different output, which is the combination of both those input layers. Whereas in the neighborhood analysis, what you can see is we'll examine the characteristics of the vicinity of the neighborhood around the location. It deals with the surrounding areas. Buffers, zone statistics, density analysis are few examples of neighborhood analysis. So for example, in the buffer, what you could see is we were studying about the neighborhood of this road. So this road is there, and we were studying the 75 meter buffer neighborhood. So that is 150 meter neighborhood of that main road, and we were studying the characteristics about those places, right? So that's why buffer is one example of neighborhood analysis, and now I think you know why we do such neighborhood analysis. So the overlay analysis determines the characteristics at a specific location by combining data from multiple layers, whereas neighborhood analysis, it considers what is nearby a location to access its suitability or characteristics. Okay. So the first thing first, to perform a neighborhood analysis, what we must have is a state with which target locations are of interest to us and what is the spatial extent. So what we need to understand is we need to have some target at first. So we'll be looking at those. We'll be looking at one example, and through those example, I'll show you if I have met all these three criteria or not. So first of all, we need to have target locations. For example, in my example, the target locations would be hospitals that are beside the main road. And then we have to determine how to determine the neighborhood for each target. So my target might be a main road and the hospitals, and I want to determine in my neighborhood, for example, a buffer of 75 meters, how many hospital centers are there. and then I have to define which characteristics must be computed for each neighborhood. So and then after determining buffer, I can just count the polygons, how many hospital centers or how many medical centers are there, or I can do other, I can determine other characteristics of the neighborhood as well as per my wish. So we'll be looking at these criteria in my other example. So let's go to the theory there first. So in neighborhood analysis, we have proximity computations in which buffer zone generation and Thiessen polygon generations are the two most popular ones, which we'll be looking here. So first, since our topic and our video is about buffer zone, we'll be studying about buffer zone. So the principle of buffer zone generation is very simple. So we select one or more target locations and then determine the area around them within a certain distance. For example, we might be seeing one example where we'll be seeing the main road. So we'll digitize a road and we'll call it a main road. And then what we would do is, so that is our target location. And what we would do is we would determine the area around them. So how do we determine? We create a buffer. So with a certain distance, we would create a buffer. So it might be a 75-meter buffer as shown here, right? So we'll be doing that in buffer zone generation. So like if you're doing it on vector, in vector-based buffer generation, the buffer themselves become polygon features. So what happens is, so this is, we do, for example, we have a shapefile called main road. And when we create buffer, the buffer would have a different shapefile layer. Okay, so it's saying the same thing. And this buffer, a shapefile that is formed after creation of a buffer, it'll be a different shapefile, and we can do further analysis in that shapefile alone. Right, so that is all about buffer zone generation. So let's look at an example of buffer zone generation. So I would be doing it from first itself. So this is my QGIS platform. So what I would do is, now we need to understand that we are working with geometric distance, right? So since we are working with geometric distance, I'll be working here in meters. So since I'll be working in meters, I have to ensure that I'll be using projected coordinate system. Since projected coordinate system works with meters, feet, etc., right? So we are not dealing with degrees, minutes, and seconds. We are dealing now in meters. So what I would do is, first I would, since I'll be doing an example of Kathmandu, what I would do is I would take UTM, projected coordinate system, and not 44 north. Kathmandu is based on 45 north. So I would be choosing, so you can see the spatial extent here. So since Kathmandu lies in this region, the eastern part of the central Pokhara, so I'll be taking this as my so what I would be doing is, okay, so here I'll be choosing the UTM zone 45 north. Okay, so apply. Okay, so I'll be having this. So what I would do first is I would import one OpenStreetMap in my layer. Okay, so I have Kathmandu here. So what I can do is I'll create a shapefile of the medical centers that are around this area. So the red plus sign which you are seeing here are all the medical centers. So what I would do is, so we have our municipality office here. Okay, is it here? No, it's here, Elot Metropolitan Office. So what I would do is I would first create a road from Kirtipur. So I'll create a road from this place to that place. Okay, so you can just fasten the video if you want. So my file name, I'll select a place, so shapefiles 4.3. So I'll be creating a different folder called 4.4 here for now. So it'll be 4.4. Okay, so I'll be creating main road maybe. Okay, save. Geometry, I'll be doing maybe a line string, maybe, yeah, I'm doing this. So the coordinate system would be 45 north. Okay, so what I would be doing is I will be digitizing now. So if you want, you can just fasten the video, you can look at it at 2x. Okay, so with the help of base map, what I would do is I would create the roads from here. So this is called digitizing. So it's one of the basic things that you do in QGIS. So what I've done is I've taken a base map, and with the help of base map, I'm creating a road feature, and in this case the road feature would act as just a polyline. Okay, so we have reached this main road, we are at Bolku, so I'll be going here, 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 here. So this is ring road right now. Okay, so I'll be now going to watch a very famous place in Lalitpur, which is Jaulak Hill. So okay, I'll be taking this roundabout in Jaulak Hill. I'm very close to LMC now. Okay, so Lalitpur Metropolitan City is okay. Right click and then I'll 1. Okay, so to make it visible, what I can do now is I'll just in symbology I'll just increase its apply. Is it seen? Okay, it's seen. I can reduce the width to 1.2 maybe. Okay, apply. Okay, so I have this. Okay, so now what I'll do is I'll just save it. Save. So I'll create a different shape file. So this time the shape file will be some points of medical. I'll just be creating some points. Okay, so what I would do now is I would digitize them. So I'll just take the Purport Hospital 1, and then I have Kirtipur Hospital 2. Okay, so there's a different hospital here, 3. So here I'm just digitizing myself to show so that this video will not just be about buffering, but will also be about some kind of digitizing, right? So that's why. But I think while you are doing your analysis, it would probably not be, you wouldn't have to digitize yourself. Mostly you'd be working with data that has been brought by other people. So for in this case, I'll consider this as my medical center as well. If I go on look, if this is a pharmacy, I won't do it. Here's a hospital, the hospital 7. Okay. Are there any hospitals here? Yeah, here's the Star Hospital. I'll be doing here 8. So we do have a hospital here as well. 9. So I'll be doing some hospitals that are out of our reach as well to show you some examples, right? Okay, so there are 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I'll just change the properties of it. Symbology, I can just change the color to maybe yellow. Apply, it's visible. Okay, so I have these many hospitals that I've digitized right now. Okay, so and then at the same time I have a main road as well, right? So if I look at the properties, what you can see is 1 2 3 4 5 6 7 8 Oh, so 7 is repeated twice. But if you look at this column, we have 21 hospitals, right? And then if you have the road, we have a single road. So now what I can do is I can create a buffer. So it's very simple. So what I do is I go to the vector, I go to the geoprocessing tools, and there is buffer. Okay, so they'll ask me what I want to create a buffer of. So main road, okay, distance how many meters. So if you don't change this to projected coordinate system, like I did at the first, if I change it to UTM, so UTM is a projected coordinate system whose unit is in meters. So if I hadn't done that, if I had worked with WGS 84, so here it would be decrease. So it would be a problem for us. So since we are doing geometrical distance thing, we have to do in projected coordinate system. So I'll create a buffer of maybe 50 meters. 50 meters, I think it's less. Let's create a buffer of 75 meters. Okay. So okay. So what I can do is okay. So run. So now you can see the buffer that has been created. So if I keep this main road just above buffer, you can see how the buffer has been created. So this is how we can do a spatial analysis in buffer. So why is buffer required then? So now what I can do is count points in polygons. So there's a feature in QGIS where we can do count points in polygons. So when I do this, what I would be doing is I would be, since we looked before that there are 21 hospitals here right now that I've digitized. Now I want to see how many hospitals lie within 75 meter of the road, right? 75 meter of this road. So I would do count. So points is medical, of course. And then I want to do in, okay. Count field. Okay, so what I would do is okay. Here. Okay, so now we have a different ID in buffered. So what we have is 15. So what does this term 15 mean then? It means that the number of points that lie in this buffer. Number of points what? The points I defined as medical. So what it means is among the 21 hospitals that I digitized here. So you could see there were 21 hospitals, right? Only 15 of them lied within this buffer. So it would give us an analysis where, for example, if we want to determine how many hospitals are within 75 meter range of the main road, so we might have to do such kind of analysis in the future, right? So this kind of analysis will help us know how many hospitals are within the proximity of 75 meters from the main road. So this is why buffer is done. In this case, what you can see is all these yellow dots are the hospitals, right? And you could see this hospital didn't come within the 75 meter buffer. So you can do measurement as well if you want to see whether it's 75 meter or not. It's almost, yeah, 75 meters, right? And then again, almost 75. I haven't done it correctly, but like it's 75 meters. So this hospital didn't come under the 75 meter buffer, whereas these hospitals as well. And if you look here, these hospitals came inside the 75 meter buffer. So these are the hospitals that are within the 21 hospitals that lie. This one didn't lie as well. This one also didn't come under the 75 meter buffer. This one also. So in this way, buffer is one kind of a very simple thing which we usually do in GIS if we want to know what are there in the neighborhood of that road or anything. For example, what we can do as well is, so here you can see there are different informal settlements, right, near the Bagmati river. So what you can see is, since recently there has been debate on what should be the right of way of the river. So for example, what you can assume is the right of way of the river is for example 40 meter, right? So what you can do is, so you might have a center line of the river, and then you can determine how many settlements are there which are illegal and how many settlements are there which are legal. So that will be our another example. So what I would do now is, so for now I would just, okay, so this is a different example, right? So now what I'll be doing is I'll be showing you a different example where we'll be, first let me digitize the informal settlements, okay? So it wouldn't be, so I will be doing a polygon, I'll be 45 north, so it might be informal, okay? So here this as well, I'll be doing it on downloads, new folder, share files 4.4. So I'll be creating, okay, informal is okay. Save and okay. So what I would be doing is I would be digitizing some settlements here. For example, I'll not be doing a very precise one. So let me say that this is one house, one. This is a different house. This is a different house. This is a different house. So let's do this house as well. Okay, for example, this is some okay, this is some few of the houses that I've digitized. Okay, so now what I would do is, so I would save it, save. I would be creating a different line, which will be so Bagmati center line. Okay, so whose coordinate system will be 45 north as well. Its geometry will be a line string. Okay, okay, so I'll be editing this as well. So let me say this is the center line of the river. Okay, so 1. So now what I would do is, so first let me change its properties to blue. Let's do it 1.2. okay, apply. Okay, so we have this river center line. So recently there was a debate on what to keep as the right of way of the river. So for example, it's 40 meter in our case, so it's a hypothetical example. So what I would do is I would create a buffer. So I would create a buffer that would be the Bangladesh center line. Okay, so meters, I would be creating a buffer of maybe 40 meters. Okay, it makes sense. This all okay. So run, close. So I have a buffer. So what I would do is I would take it here. Okay, so now you can see which settlements are encroached, right? So this is a very simple example where you can count how many settlements have encroached. In this case, this hasn't encroached, these 3 have encroached, and these at the Lalitpur side has also not encroached. But if you have multiple many polygons, it's not possible for you to count, right? So in that case, what you would do is, like just I had done before, you would do here, you would do so which buffer is our example then? So let me first change the name, green. So I would change its name to I would rename it, the layer's name would be buffer Bagmati. Okay, so this would be my name, and then I would count polygons, and then the name would I just want to see not medical centers, but I want to see buffer Bagmati. Polygons is informal settlements, right? Okay. So polygons is this, point is oh sorry, this is just count points in polygon, count. So do we have such feature or not? Oh, I don't think there's a feature like. So अब यसको केसेसमा चाहिँ सो हाम्रो जसरी यहाँ काउन्ट पोइन्ट पोलिगन भनेको थियो, काउन्ट पोलिगन इन पोलिगन भन्ने फिचर चाहिँ हुँदैन. तर what we can do is हाउ डु वी क्रिएट अब हामीलाई त कहिले चाहिएला नम्बर कतिवटा छ अथवा हामीलाई चाहिँ त्यसको एउटा छुट्टै सेप फाइल चाहिएला सो इन द्याट केस वाट वी क्यान डु इज वी क्यान सिम्पली गो टु भेक्टर so there's analysis tools there's a research tool in this we can do select by location so what we can do is हामीले select features from कताको select features गरेर हामी informal यो जुन पिङ 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 छ यसको informal सेलेक्टमेन्ट्सहरू सेलेक्ट गर्नु पर्यो त्यसमा के सेलेक्ट गर्नु पर्यो भन्दा intersect भनेको चाहिँ यो फिचर्स यो इन्फर्मल सेटलमेन्ट्स पनि पढ्नु पर्यो अनि त्यो सेटलमेन्ट चाहिँ मेरो केमा पढ्नु पर्यो भन्दा मेरो बफर्ड भएको चाहिँ पढ्नु पर्यो यसरी सेलेक्ट गऱ्यो भने चाहिँ रन गऱ्यो भने सो दिज फाइल्स विल बी सेलेक्टेड वाट आई क्यान डु इज आई क्यान डु मैले अब एक्सपोर्ट गर्नु सक्छु सो सेभ सेलेक्टेड फिचर्स एज भनेपछि मैले चाहिँ यसलाई एउटा सेभ फाइल बनाएर यसलाई चाहिँ मैले के नाम राख्न सक्छु भन्दा चाहिँ इन्फर्मल विदिन 40 मिटर भनेर एउटा सेभ फाइल बनाएँ ओके यसको 40 जोन ओके गऱ्यो भने अब चाहिँ मेरो एउटा सेपरेट सेभ फाइल आयो जुनमा चाहिँ आई जस्ट ह्याभ दिज 3 फिचर्स हैन जुनले चाहिँ त्यो हाम्रो बफरमा इन्टरसेक्ट गरेर बस्दो रहेछ भनेर आयो नि त हैन सो इन दिस वे एज वेल बफर क्यान बी युज सो बफरको चाहिँ धेरैवटा युजहरू हुन्छ यो दुईवटा भनेको चाहिँ दुईवटा युज केस हो विच आई सोड यु गाइज इन दिस भिडियो थ्याङ्क यू